Welcome back. In this portion, we are going to cover the receiver operating characteristics. Now, instead of plotting precision versus recall, the ROC curve plots the true positive rate, which is another name for recall, against the false positive rate. The false positive rate is the ratio of negative instances that are incorrectly classified as positive. It is equal to 1 minus the true negative rate, which is the ratio of negative instances that are correctly classified as negative. The true negative rate is also called specificity. Hence, the ROC curve plots the recall versus 1 minus specificity. Okay, let's look at this chart that I prepared earlier. So if you look at this, the false positive rate is equal to the false positive, which is this one here, divided by the true negative, which is this one here, plus false positive. So the false positive rate is basically this divided by this whole thing. Okay. Now, the true negative rate really is just the inverse, or not so much the inverse, 1 minus this thing here. Okay, this is the true negative rate. Okay, recall the true negative rate is the ratio of negative instances that are correctly classified as negative, so which is really this one here. Let's move on to run some codes. We're going to import the ROC curve. And we're going to extract these from the train and scores and then plot it. Let's visualize that and see what it looks like. Okay, so this is the ROC curve. This solid black line here basically say this is our benchmark for basically any randomized 50-50 so-called prediction or classification. So in order to be, how you read this is the closer it is to this, to the left, top left corner, the better it is. So if we import the RUC, area under the curve, score, if we plot that, it's 99.22. So anything that's below this is called area under the curve. So we use the PR curve, which is what we were using earlier. PR is the precision recall curve. Where do we draw that? Did I just miss that? This is, yep, this precision recall curve. We use this when? We use this whenever the positive class is rare, or when you care more about the false positive than the false negatives. Remember, false positive, false negative. Okay, so you care about the false positive than the false negatives. You use the ROC curve whenever the negative class is rare, or when you care more about the false negatives than the false positive. Okay, when you care more about. In the examples above, the ROC curve seems to suggest that the classifier is good. Okay, remember you use ROC when the negative class is rare. So is the negative class rare in our case? Let's have a look here. We have to look at the confusion matrix. So remember, this is negative class, this is the positive class. Okay, so when you look at this, there are actually a lot of negative class, very few positive class. So looking at this, obviously it doesn't suit in this case, because in our case the negative class is 9 times more than the positive class. So in this case, ROC curve basically say, hey, this is great. But when you look at the position recall curve, which the positive class is rare and which is correct in our case, then it tells you the story, a different story altogether. So there are definitely room for improvement. So what we're going to do now is that we're going to use advanced model just to illustrate the point. I'm going to just use random forest. Yes, it is an ensemble method. I just want to give you a teaser for this. I won't be going through this in depth. I just want to run through this model just so that you can actually have a comparison and understand how the precision curve as well as ROC works, and plot them, the two of them together. The dotted line is the stochastic gradient descent. The random forest is this solid black line. You notice that the random forest far supersede the performance of the stochastic gradient descent, and the ROC under the curve also testify to that. So it's 99.71 or 0.997172 versus 0.9922. Okay, so I hope that has been useful. So let's just do the fit, and for the classifier for random forest, and we're gonna have a look at the precision score as well, and the recall score as well. And if you look at the confusion matrix, it's much better than the stochastic gradient descent. So if we come over here to the stochastic gradient descent, we want to look at the precision score using normal threshold rather than the modified threshold. Let's see, where is it? Okay, there we go. So let me just, rather than scrolling up and down, I'm just gonna use this. That's not correct. Okay, let's do this. Okay, now I can go down to the end and compare. Okay, our precision score is 88.5, much lower than the random forest. Our recall score is 93, which is marginally worse than the random forest. So this is to illustrate that the couple of things, in that the stochastic gradient descent is not as good as random forest in this case. I hope this tutorial or this lecture here has illustrated a couple of key concepts here about the receiver operating characteristics. We've already gone through the PR, precision recall curve, the trade-off earlier. This ROC is for different situations whereby that you can make use of it. So bearing in mind, this is really the key point of this class. The PR really is when your positive class is rare, ROC is when your negative class is rare. We have come to the end of the lesson on receiver operating characteristics, the ROC curve. We've also covered the ROC area under the curve, which is this one here, and we actually computed the score as well. And we took it that went on to further compare our model, which is the support vector machine, and compared against the random forest. And we find that the random forest actually perform much better than our support vector machine model. So, or linear support vector machine. So with that, we have come to the end of the lesson. I hope you found that useful as a comparison and to understand the actual mechanics and the performance measures that we used. When you come back, we're gonna apply all of these things that we've learned and look at what happened on Titanic. And look forward to seeing you in the next video.